Today we are going to add two polynomials. Typically in the Algebra 1 regions, you see it written in this form. What is the sum of negative 3x squared minus 7x plus 9 and negative 5x squared plus 6x minus 4? So we know that the word sum means to add. So we would set it up as follows. Negative 3x squared minus 7x plus 9. So that's the first polynomial in the word problem. And then the addition symbol because of the word sum. And we have negative 5x squared plus 6x minus 4. And before I do anything, I'm just going to go back and make sure that I wrote the problem correctly and I don't do a transferal error, an error that one makes when writing down a problem. So here's my setup. So once we're there, then I can move on to solving the problem. And I'm going to group the two polynomials vertically by like terms. So I'm going to start with my first polynomial, and the order doesn't matter which polynomial I write down first, because when we add, order doesn't matter. Addition is a commutative property, which means the order of how I add the same numbers doesn't change your sum. So for example, 2 plus 3 is going to give me 5, while 3 plus 2 is going to give me 5. So I just brought down the first polynomial as this, and ideally in standard form with the greatest exponent, and then I work my way down to the smallest exponent. We have here the exponent of 2, and then when you don't see an exponent, there is an exponent, it's just an invisible 1. And you can go ahead and add the exponent of 1 when you don't see 1. So we start with the term with the highest exponent, work our way down to the constant, the number by itself. Then I'm going to take the second polynomial and I'm just going to rewrite it underneath this other polynomial. I'm going to bring down the negative 5x squared, and I'm going to be underneath the x squared term, so they're like terms. They have the same variable and the same exponent. Then I'm going to bring down the x term, and it's a plus 6x. And then I'm going to, again, remember if I don't see an exponent, it's because there's an invisible exponent of 1. And then I'm not going to forget the minus in front of the 4, the minus 4. So they're now lined up vertically by like terms. Same variable, same exponent. And then these don't have any variables, but all numbers are like terms. I can add and subtract all numbers. So first column, now that I have converted it from horizontal to vertical, I can just add. So if negative 3 plus negative 5 is going to give me negative 8. And the variable and the exponent don't change when we are combining like terms. Then we have negative 7 plus a positive 6 is going to be negative 1x. Now I could choose to draw the invisible 1 or not, but remember when we're adding, we're not changing the variable and we're not changing these. We're adding two terms of x to the first power, so I'm still getting a term of x to the first power. Then a positive 9 minus 4 is going to give me a positive 5. And the answer is in lovely standard form. This is why I added to get the negative 8. Notice this is what I get it to negative 1, and this is why I added. So just in case you're having a hard time visualizing the numbers, the variables stay the same. I'm just worrying about the coefficients when we have variable terms, and I'm just adding the numbers down. Let's do another example. So now we're being asked to find the summation of, and we have here, this polynomial x squared minus 9, and then the other polynomial 3x squared plus x plus 8. And again, like I said, in typical Regents problems, this is in a word problem format. So I'm going to start by setting up the problem. The setup, like in the prior problem we just did, we are adding x squared minus 9 plus 3x squared plus x plus 8. Before I move into the step of combining them by like terms vertically, I'm going to get my other color and I'm going to put a variable right here. I'm an exponent. So when we don't see an exponent, the invisible exponent is 1. These two terms already have exponents. And then when we don't see a coefficient in front of our variable, then it's a 1, in this case a positive 1 because of the sign. And similarly here, we don't see an exponent and we don't see a negative sign in front, so it's just a positive 1. Oh, I said exponent, I meant variable. Sorry about that. Okay, so now we're going to bring down. Now, one thing that you may notice is the first polynomial here only has 2 terms, so we call it a binomial bi for 2. And this polynomial here has 3 terms, so we call it a trinomial. Notice that this first polynomial is, for some reason, went from an x to the second power term to directly to a constant, so it's missing its x term. And there are a couple of ways you can approach this. You could just say, well, you know what, I'm going to leave room, a space for that x term. So I'm just going to do negative 9 here. The other way you can think of it is, like, you know, technically there is a x term, we just don't see it because there are 0 x's in this polynomial. And if you go back to my older video about combining like terms, a coefficient in front of a variable is really that number times the variable. There's always going to be there's always an invisible multiplication sign between the coefficient and its variable. We just don't put it there because it's invisible, just like the invisible exponent of 1 and the invisible coefficient of 1 when we don't see one. And when you think about 0, when you multiply 0 times any number, your answer is always going to be 0. Like 0 times 9 is 0. So 0 times their variable is going to go 0. It's going to equal the number 0. And if this is equal to 0, if we add 0 to any number, then it doesn't change the number. So again, a good placeholder, either you have just an empty space for the x term because this binomial only has these 2 terms, or you could say, you know, technically there is an x term, it just has a 0 as its coefficient. So then we have all 3 spaces, x term space, x to the first power space, and then constant space. We can now bring down the second polynomial underneath the correct like term column. So if we kind of work backwards, we have a plus 8. The 8 is not going to go underneath these columns. It's only going to go underneath the number because numbers are like terms. Then I'm going to bring down the plus 1x. I'm not going to bring the plus 1x here because they are not like terms. Both have the same variable, but they have to have the same exponent in order for 2 terms to be like terms. So when we bring down that plus 1x to the first power, we're going to bring it down into the middle column, so they are underneath like term. Then we have the positive 3x, and that's a positive, so I can add the positive there. When we don't see a sign in front of a number, we know it's positive. So now I lined both polynomials by like terms vertically. And that's how I'm going to add down. So the first term, I have x squared terms. I have 1x squared plus 3x squared is 4x squared. Then the second term, I have an x to the first power, the invisible first power. So I have 0 x's plus 1x. 0 plus 1 is just 1. I don't have to have the coefficient of 1 or the exponent of 1, but it doesn't hurt to have it. Then I can combine numbers. Numbers are always like terms. -9 plus 8, -1. If you were to try to look at this answer in a multiple choice in the regions, that invisible exponent of 1 and the invisible coefficient of 1 would be there in the answer choice. Okay, I hope this makes sense. I recommend practicing. There's plenty of worksheets out there for free that you can practice with answer sheets. Try them on your own first and then check your answers. And when in doubt, use your calculator when adding, especially if you're adding negative numbers to positive numbers. Take care.